So there's two ways of really looking at formulas for risk. One is the absolute risk. We're using the standard deviation of something, and in this case it's standard deviation of g, so the standard deviation sign here, and then the subscript g, so standard deviation of g. And you would read this as the standard deviation of growth. The formula is the standard deviation of growth is equal to the standard deviation of the return on assets times the assets to equity times k, which is that percent you keep, the 1 minus t times the 1 minus c. 95% of the time, the actual amount's going to be within 2 standard deviations of the expected result. So if we took that expected growth rate that we found, 7.2%, and added 2 standard deviations to it and subtracted 2 standard deviations to it, 95% of the time we would be within that range. That's just one way to interpret a standard deviation. So larger standard deviations mean more risk. Another way to calculate risk and to think about it is relative risk. And it's relative because it's relating our measure of risk, the standard deviation, to something else, and in this case the expected growth. So the coefficient of variation is the name, and it is the risk per unit of return. So a higher coefficient of variation means higher risk per unit of return, and so a lower one would mean lower risk per unit of return. In this case, the coefficient of variation is the standard deviation of growth divided by the expected growth. Here, I put the expected growth in bold, and a lot of times I'm going to put it in bold and red rather than putting the bars above it because I think it's a little bit easier to see. And that just says what we did. So farmer C, our example again, I've still got the bars here just so that you remember that it's an expected growth and expected return on assets we're using. Here's our growth formula. So in this case, it's the standard deviation of R times the assets to equity times K. Standard deviation of R is 6%. Assets to equity is 1.5, one bigger than our debt to equity ratio, times the percent we keep, K, and K is 1 minus T times 1 minus C. So 80% times 50% gives us 40%. We calculate that out, we get a 3.6% is our standard deviation of G. Our coefficient of variation, remember, is a relative measure of risk, so we're relating the standard deviation of G to G. And so in this case it's 0.036 divided by 0.072, or a 0.5. So now we're just going to get a little bit more complex with our formulas because we say, well, what if they experience both return on asset risk and interest rate risk? Still the same situation, but now instead of just having the return on asset risk of 6%, we also have an interest rate risk of 4%, standard deviation of I. So here we have the expected growth is equal to the expected return on assets times the assets over equity minus the expected cost of debt, or the expected interest rate, times the debt over equity, times 1 minus T, 1 minus C. This 1 minus T, 1 minus C could also just be shortcutted and K could be used. So farmer C, their growth rate when we calculate it out is 7.2%. Now they have a much harder formula to use for their standard deviation of growth, and there it is. It's the standard deviation of the return on assets squared times the assets over equity squared, plus the standard deviation of I, their interest rate squared, times the debt over equity squared. This whole thing is multiplied by K squared, and then after we multiply all that out, we take the square root of it to get our standard deviation of G. If we didn't take the square root of it, it would be the sigma G squared, or it would be the variance. So if you've heard of variance instead of standard deviation, the standard deviation is always the square root of the variance. So what's inside these brackets here would be the variance, and then we take the square root of that, and that gives us the standard deviation. The standard deviation is more easy to interpret, and so we always find the standard deviation. So here I've just kind of put in the numbers here. Our 6% return on assets risk times the assets over equity squared plus 4% is the standard deviation of I. We're right here. Multiplied by 0.5 squared, the debt to equity squared. And then this whole thing would be multiplied by 0.4, which is K squared. And then the whole thing would be take the square root. When you do that, you get 0.037 or 3.7%. Our coefficient of variation is the standard deviation of G over G. So it's the same formula as before, so it doesn't matter how you determine the standard deviation of G. You just always take standard deviation of G over G. But in this case, since we had both interest rate and return on asset risk, it was 0.037 divided by 0.072, and so it's a little bit higher. We get a 0.51.